Hey there! Welcome to Life Noggin. So we know quite a bit about the Earth's core, but there's still a lot that we don't know. So in today's video, we're going to take a journey to the center of the Earth. So let's start from the surface. You're watching this from the surface right now. The Earth's crust is the outermost solid part of the Earth. It might seem pretty unchanging, but it's actually quite dynamic. On top of the crust is the lithosphere, which includes the crust and the uppermost part of the mantle. The rigid rock of the lithosphere is broken into tectonic plates that move around on the weaker, hotter, more fluid layer below it called the asthenosphere. These plates move because the asthenosphere is in constant motion due to currents created by the heat rising from the core. That heat also comes from the radioactive elements within the Earth's mantle itself. The temperature of the mantle increases with depth, becoming so hot that the rocks begin to behave like a very viscous liquid. At the boundary between the mantle and the core, the pressure is about 3.6 million times the pressure we experience at the surface, and these high pressures prevent the rocks from sinking down into the core. Instead, they form a rigid layer known as the D+2 layer. And now we get to the core. Between the mantle and the radius of the Earth, the core makes up 1/8 of the Earth's volume and half of its mass, and it starts with the outer core. The outer core is a liquid layer of mostly iron and nickel. It's about 2,200 kilometers thick, and its temperature ranges from 4,000 to 5,000 degrees Celsius. Because the outer core is liquid, it's able to move, and this movement generates electric currents. These electric currents, combined with the Earth's rotation, generate the Earth's magnetic field, which, as I mentioned before, protects us from harmful solar radiation. And then we get to the inner core. The inner core is a solid sphere with a radius of about 1,220 kilometers. The temperature of the inner core is over 5,000 degrees Celsius, which is as hot as the surface of the sun. Despite being this hot, the inner core is solid due to the immense pressure of over 360,000 times atmospheric pressure. This pressure is so great that it prevents any further compression of the core. The inner core is also made mostly of iron and nickel, but it has a small amount of lighter elements, including sulfur, oxygen, silicon, and phosphorus. These elements make the inner core slightly less dense than the outer core. So that's the Earth's core. We can't drill down to it, but thanks to seismic waves generated by earthquakes, we've been able to learn a lot about what's inside our planet. So, what do you think? Did you learn anything new? Let us know in the comments below, and don't forget to subscribe. All the sources used are added in the description below. As always, this has been your host. Don't forget to keep on thinking.